Hello teachers, welcome to chapter 6. This time we're going to discuss section 6-3, which covers multiplication, division, and estimations with rational numbers. Students will be able to understand and explain multiplication and division of rational numbers, properties of multiplication and division of rational numbers. We're going to talk about estimation of multiplication and division with rational numbers and extension of exponents to include negative integers. And that last part, dealing with exponents, there's a lot of that in the homework, and I think you might find that the most challenging part of this section. So what does it mean when you multiply rational numbers? We also call those fractions. Well, one way to take a look at it is with repeated addition. So if you look at that first model, we're multiplying 3 times 3/4. And so you'll see that we have 3 different circles that represent 3/4. Notice each circle is divided up into 4 equal parts. That represents the fourths, and 3 of them is shaded. Now, we know from a previous section when we defined multiplication originally on the whole numbers that it really repeated addition is what multiplication is. So 3 3/4, we just add 3/4 3 times, and we know how to add rational numbers now from a previous section. So we have 3 plus 3 plus 3 is 9, and of course each of those is a common denominator already, which results in 9/4, which is equivalent to 2.5. And if you just count your shaded regions, 1, 2, 3, 4, 5, 6, 7, 8, 9, that represents the 9. And if we filled up entire circles, that's 4 and 4 is 8 of them with 1 left over, and that represents the mixed number 2.5. Now, that's not going to account for every situation you have. Look at the second, where we're representing this with area. And, you know, multiplication can be represented with area. You have the number of rows times the number of columns. Here we're trying to multiply, I'm going to highlight it over here at the bottom right, 1/2 times 3/5. And you'll see we have 3/5 represented here. We have a rectangle where 3 out of 5 of the divisions is shaded in to represent 3/5. If we want to take half of that, what we do is just cut that in half. Now you'll notice, and you look at the picture to the right, that's better, but 3/5, the answer to that is 3/10. Why? Well, check out how many pieces you have now. It's divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this shaded part is the 3/10. So we can represent fraction multiplication with sets or in the area model. Now I'm going to bring up next a definition. So definition of multiplication with rational numbers. If we have A over B and C over D are rational numbers, now we know some important stuff also. I should say that B is not allowed to be 0. And D is also not allowed to be 0, because that's the definition of a rational number. Your denominator is not 0. Then to multiply, it's really pretty easy. You just multiply numerator times numerator and denominator times denominator. No need for a common denominator to pull this off. Just numerator times numerator, denominator times denominator. So I'm going to pull up an example. If 5/6 of a population of a certain city are college graduates, and 7/11 of the city's college graduates are female, what fraction of the population of that city is female college graduates? So 5/6 of the population of a certain city are college graduates, 7/11 of the city's college graduates are female. What fraction of the population of that city is female college graduates? So 5/6 of 7/11. We could think about it that way. 5/6 of 7/11. And especially when you're talking about fractions or rational numbers, when you say the word of, often that represents multiplication. So we're multiplying 5/6 times 7/11. You know, we kind of avoid using that symbol these days. It's 5/6 and then use the dot 7/11. And then we have the property that When you multiply fractions, you multiply numerator times numerator. So we have 5 times 7 is 35. Denominator times denominator, 6 times 11 is 66. And we want to write that result in simplest form. And 35 divided by 66 is simplest form. How could I know that so quickly? Well, you could run through the divisibility test, but here's what I'm looking at. I'm looking at to see if numerator and denominator, whether straight up and down in one fraction or across, simplifies. So 5 and 6, the greatest common divisor there is 1, so that doesn't simplify. Same thing with 5 and 11. Look, 6 and 7, the greatest common divisor there is 1, and same thing with 7 and 11. So I know now that this 35 over 66 does not reduce. Now I've got this typed up for you, so let's discuss it. It says 7/11 of 5/6 is 7/11 times 5/6 is 35 over 66. The fraction of the population who are female college graduates is 35 over 66. This is exactly the way we handled it. Again, notice the simplifying beforehand. We'll try to do that with other problems. All right, let's talk about properties now. You have identity and inverse properties of multiplication of rational numbers. So the first one is what we call the multiplicative identity. What is that? Well, if you multiply a rational number, i.e. a fraction, by 1, don't you just get the same answer? You get the identity. So the multiplicative identity of a rational number is 1. 1 times any fraction is just that fraction. And notice you have to do this commutatively. So 1 times AB is the same as A over B. I said AB. A over B times 1, which is simply just AB. Okay? We also have a multiplicative inverse. This is called the reciprocal. So you'll hear me call this the reciprocal when we're using it to solve problems, but the multiplicative inverse is something that you multiply a number by to give you the identity, which is 1. So if you take A over B and then you multiply it by the multiplicative inverse, which is called the reciprocal, which is B over A, then you get an answer of 1. And remember how we talked about canceling? Look, this B and this B, those are common factors, so when we divide that out, they cancel. This A and this A are common factors. When we divide that out, it cancels, and you get 1. Now, the long version of that is you get AB divided by BA, which the commutative property says I can write that as AB, and AB divided by AB is 1, right? But you can do that canceling thing as long as you're multiplying. Notice commutative too. You could do this either way and multiply to get 1. We also have a distributive property, and it's over addition and over subtraction. So just like when we were dealing with whole numbers, we had a distributive property over addition and over subtraction, and we had a distributive property over addition and subtraction when we were working with integers. Now this is true also for rational numbers. So we're allowed to multiply A over B times C over D, and that gives us A over B times C over D, and then multiply A over B times E over F, which gives us AE over BF, and the addition sign stays addition. And we can do this as well with subtraction, and subtraction stays subtraction. So the properties that you know about whole numbers and about integers also applies now to rational numbers. What else? The multiplication property of equality. So what is this saying? Notice to the left, if you have a fraction equal to another fraction, then you are allowed to multiply both sides of the equation by the same fraction. So if A over B equals C over D, then if you multiply the left side by some fraction, E over F, then you have to multiply the right side by some fraction, E over F, to maintain equality. Just like you do for whole numbers and for integers. All right. Now, here, this is if you're dealing with inequality. So notice the difference. So if you have an inequality, A over B is bigger than C over D. So the left-hand fraction is larger than the right-hand fraction. And E over F is a positive value. So I want you to make sure you realize that this fraction E over F is positive. Then what you can do is you can multiply both sides of the inequality by E over F, and look, the direction stays the same. Okay, so if you multiply by a positive fraction or even a positive integer or even a positive whole number, the direction of the inequality stays the same. On the other hand, look at the other one. Right here, if E over F is less than 0, which means it's negative, and you multiply your inequality by E over F on both sides, when you multiply a negative, remember what happens? The direction of the inequality switches. So be very careful, common mistake with students, when you multiply by a negative value, whether it's integers or rational numbers, the direction of the inequality switches. Okay? What about when you multiply by 0? You get 0, right? This is true for whole numbers, this is true for integers, and now we can say this is true for rational numbers as well. Some fraction A over B times 0 is equal to 0. Same thing as if we multiply by 0 times A over B. And that multiplication by 0 property has to work both ways for it to be true, and of course that does. Now, let's do an example. So we have a bicycle is on sale at 3/4 of its original price. Now this is not how much off it is. This is 3/4 of its original price. Remember I said when you have a fraction and then you have the word of, that typically means multiply. Okay, I'd be hard pressed to make up an example where it didn't. So 3/4 of its original price. If the sale price is $330, what was the original price? Okay, now notice they set us up already. Let X be the original price, because we don't know that, right? So if we take 3/4 of the original price, that's saying 3/4 X equals the sale price, 330, then we need to solve this equation. Now to get this X by itself, I'm going to show you a trick. We're going to divide this side by 3/4 and divide this side by 3/4. But if you'll recall, we haven't defined division with rational numbers yet. But I got a trick for you, okay? I'm going to use that multiplicative inverse. Remember the multiplicative inverse? What is it? It's the reciprocal, right? So I'm going to multiply the left-hand side by 4/3, which is the multiplicative inverse of 3/4. Also called the reciprocal, and I'm going to use that property of equality that if we multiply the left side by something, we must multiply the right side by that same value. Now how did that help us out? Well, check out what cancels. This 3 cancels with this by division. 3 divided by 3 is 1. This 4 cancels with this 4, so I'm only left with X on the left hand side. Now what about the right hand side? Well, we know that this 330 is really over 1. Now, if you wanted to right now, you could go straight across and multiply 330 times 4. I'm just going to write that there. And then 1 times 3, and then reduce that. But what I'm noticing right off the bat, instead of doing it that way, I'm going to say 3 divides into 330 110 times. Then I'm going to say 110 times 4 is 440. And by the way, that canceled to give me 1, and 1 times 1 is 1. And we know 440 divided by 1 is just 440. Now, we're talking about what units? We're talking about a price, an original price. So that would be $440 is the original price. Now, of course, I've got it typed up for you, so let's pull that up. A bicycle is on sale at 3/4 of its original price. Remember, I'm just rereading. So let X be the original price. Look at the setup here. 3/4 X equals to 330. And then they multiplied. Remember, that's called the reciprocal, which is really the multiplicative we're trying to get the multiplicative inverse. So 4/3 times 3/4. And that gives me x is equal to 430. They didn't show you the cute little trick to give us 440, easily, but you understand that, I know. Now look at these two problems, or one problem. We want to use improper fractions to multiply 2.5 by 2.5. And notice it says improper fraction. You remember what the definition for an improper fraction is, right? That's where the numerator is larger than the denominator. And remember, we know a quick way to change 2.5 to an improper fraction. Now you can look at it as, remember from the other video, 2 plus 1/2. You could write as 2 over 1, and then you could find a common denominator. So that would be 4 over 2 plus 1/2 gives you 5/2. But I bet if you teach this material, you'll show it this way originally, because you want your students to really understand what's going on. But then the fast way to do that would be to say 2 times 2 is 4 plus 1 is 5. So that would be 5/2 times, again, 2 times 2 is 4 plus 1 is 5/2. And we know how to multiply fractions. 5 times 5 is 25. And then 2 times 2 is 4. And that is in simplified form. Now here they want us to use the distributive property. So they don't want us to change it to an improper fraction. Can we do that? You bet we can. So how about we write 2.5 as 2 plus 1/2. And then we're going to multiply that times another 2 plus 1/2. Okay, we haven't used the distributive property yet. We've just defined a mixed number here. Now, I'm going to distribute the entire 2 plus 1/2 over this addition sign. So this is going to be 2 plus 1/2 times 2 plus, and then 2 plus 1/2 times 1/2. Now I get to use the distributive property again. This 2 is going to multiply on each side, and this 1/2 is going to multiply to each on the inside. So that gives me 2 times 2 plus 1/2 times 2. And then in the other, using the distributive property again, 2 times 1/2 plus 1/2 times 1/2. Now we know 2 times 2 is 4. Hey, we know half of 2 is 1, right? Make that easy. Plus 2 times 1/2, which is half of 2 is 1, plus 1/2 times 1/2 is 1/4. Now 4 plus 1 is 5, plus 1 is 6 and 1/4. Now that answer looks different than what we have here, but we know that's the same thing, right? We say 4 divides into 25, 6. 6 times 4 is 24, and 1. Remember the way to change an improper to a mixed number? This definitely is 6 and 1/4. So there it is using improper fractions, which I'm a big fan of the improper fraction method. But you also want to be able to do this with mixed numbers so you can show your students why these are the same, and it wouldn't matter which way you did it. Although I definitely say the first way is easier. Notice this, just the space issue alone. So let's look at the typed up version of this, and notice we did the same thing. They changed 2.5 to 5/2 quickly, numerator times numerator, denominators times denominator, and then they changed that back to a mixed number. And then below, they changed 2.5 to 2 plus 1/2, which is the definition of a mixed number, times 2 plus 1/2, and then we distribute. Now notice they distributed backwards. Is that okay? Sure it is. We distributed the parentheses into the second set. They distributed the second set of parentheses into the first set. Why is that okay either way? Remember the multiplication property, which is commutative. Yes, the commutative property of multiplication. That's exactly why. Now let's spend a little bit of time talking about division of rational numbers with some models. So it says how many 1/2 are in 3 wholes. So how do we express that? Well, we draw 3 holes. They're all shaded in, and we divide them into 1/2 to figure out how many 1/2s are in 3 wholes. And you can count your 1/2s, right? There's 1, 2, 3, 4, 5, 6. So we know that 3 divided by 1/2 is 6. Okay? Another way you could do it is just work with a single circle to represent a whole. How many 1/8s are in 3/4? So the first thing that we do is shade in 3/4. So if you were looking at that, so here is a 1/4, here is a 1/4, and there's your third 1/4. And then we divide it into 8s because we need to know how many 1/8s are in 3/4. In other words, we're representing 3/4 divided by 1/8. And then you just divide that into 8 and you see 1, 2, 3, 4, 5, 6. There we go. Now you could also do this with a number line. Might be slightly more confusing, but we can do this. How many 3/4 are in 7/8? So we start with, and again, what are you actually modeling? You're modeling 7/8 divided by 3/4. So we're asking how many of these fit in here. So the first thing we do is represent 7/8. Notice that's all the way here in gray. But then we look at 3/4 within that. That's your green shaded there. So it says the bar length of 3/4 is made up of 6 equal pieces of 1/8. So you see 1, 2, 3, 4, 5, 6. So there's 6, but then there's some left over. So let's keep going with this story. It says there is at least one length of 3/4, not 6, but one length of 3/4. If we put another bar length of 3/4 on the number line, so what they did, so here's your second bar length of 3/4. So that starts where we left off 3/4, and then we go to 6/4. That's the second bar length. We see there is one more of the 6 equal length segments needed to make 7/8. So we needed one more right there. And so that's where the 1 comes in, which is the green, and then the 1/6 was the leftover part. How much of 3/4 was that? And again, that was 1/6. Now, that's a little bit more to think about. You may want to go back and look at that picture on your own or just pause it and really think about that before you move on. But the definition's not so bad. I had to line myself back up, didn't I? Let A over B, C over D, and E over F be rational numbers such that the fraction C over D is not 0. Why? Because remember, you're not allowed to divide by 0. So notice C over D, this guy right here can't be 0. I'm dividing by C over D. That's exactly why C over D couldn't be 0. So they go on to tell us that A or B divided by C over D equals some answer E over F. If and only if E over F is the unique rational number such that C over D, what you're dividing by, that's your divisor, times E over F is equal to your dividend A over B. What is this really expressing? That division is the inverse operation of multiplication. Remember, we divide to find division that way. Division is the inverse operation of multiplication. Okay? Now, when two fractions with the same, hold on, let me line back up again. When two fractions with the same denominator are divided, the result can be obtained by dividing the numerator of the first fraction by the numerator of the second fraction. I was like, that doesn't sound right. The numerator of the first fraction by the numerator of the second fraction. But when could you do that? Again, when the denominators are the same. They have the same denominators. That's the important thing. To divide fractions with different denominators, we rename the fractions so that the denominators are equal. Okay, but look what really happens, y'all. If you have A over B divided by C over D, they found a common denominator. Okay, so what happens is you flip, right, because you're really dividing the numerators, which means you flip it, all right, and you end up with this expression at the end. So A over B divided by C over D is the same thing, let me write this, is A over B times D over C. Does that not give us that right there? That's AD over BC. I know you've heard it. Keep change, flip. Let me write that down. Keep, change, flip. What in the world does that mean? It means keep your first fraction, change your division to multiplication, and you flip your second fraction, which is the reciprocal. So change to multiplication and multiply by the reciprocal. All right, so we have another example. A radio station provides 36 minutes for public service announcements for every 24 hours of broadcasting. I bet you've heard that before. You've ever listened to a radio station late at night, and I think they play all 36 minutes between like midnight and 3 in the morning. Seems like more than that, though. What part of the broadcasting day is allotted to public service announcements? So what are we really trying to do? We're trying to find a fraction that represents the public service announcements out of the entire day. So notice this, that the 36 is in minutes, whereas a day is in 24 hours. We need to be speaking the same language, right? So how many minutes are in a day? So the first thing we could do is do 24 hours is equal to how many minutes? How could we figure that out? Well, 1 hour is 60 minutes. So if we say 24 and we replace this hour with 60 minutes, we're going to find out how many minutes are in a day. And 24 times 60, now that was 1,000. Come on, pen, write. 1,000. Still not writing. That was 1,000. Still not writing. 440. There we go. Excuse my frustration. Okay. So that's like your whole, right? That's how many minutes are in a day. That's going to be my denominator. What goes in the numerator? My 36 minutes. As a matter of fact, if I used units, that would be 36 minutes on top and 1,440 minutes on the bottom. The minutes cancel out. Now, I need to reduce this fraction to lowest terms. Listen, I know they both divide by 6, so at least let's do that. 36, I can write as 6 times 6. 1,440 is equal to 6 times 240. Notice I didn't pick big enough. What numbers go into both of those? Hey, 6 go into both of those. So 6 I can write as 6 times 1. 240 I can write as 6 times 40, can I? And then the 6's cancel again. So my answer is 1 out of 40. 1 minute out of every 40 minutes has to be allotted to public service announcements. And if they would have spread those things out from midnight to 3 or 4 in the morning out, just 1 every 40 minutes, that'd be a whole lot easier for folks to take. That's my speech for the day. Let's do another example. Oh, there it is. It's just spelled out. I forgot the typed up version. But see, look, there's that 1 out of 40 that we were talking about. 1 over 40 of the day is allotted for announcements. How many 3/4 minute public service announcements can be allowed in the 36 minutes? Okay, so now we've got 36 minutes still, right? They want to know if you make a service announcement 3/4 of a minute long, right, which would be 45 seconds, but we don't have to convert that. How many would you have? So what type of problem is this? Well, I bet if we take our 36 minutes and we split that up, which is a division, right, into 3/4 of a minute pieces, we would have it. So here's our setup. 36 divided by 3/4. You remember that trick that I told you? That keep, right, change, flip. Yeah, you change it to a multiplication problem and multiply by the reciprocal. Is this an issue? No. Put that 36 over 1. How many times? Hey, you want to cancel beforehand? I noticed that 3 goes into 36. Watch this. So 3 goes into 36 how many times? 12 times. 3 goes into 3 1 time. And then I multiply and get 12 times 4, we know that's 48. And then 1 times 1 is 1. So that would be 48 announcements. I'm just going to make that ugly. That says announcements, right? Probably got this typed up too. Let's check it out. There we go. 36 divided by 3/4, which is the same as 36 times 4/3. Again, keep, change, flip. Gives me 48 announcements. I have just hit my 30-minute mark, y'all. So let's shut down part 1. We'll come back for part 2. I got a bunch of slides. I'm on slide 25 of slide 65. So there's probably going to be a part 3 also. But I'll try to go as fast as I can go and still make it make sense. I hope you have a wonderful day. Take care. Let me know if you have any questions about any of this material.